Now we're going to talk about real-world graphs and how to read them. So now we know something about domain and range. We're going to be using that vocab to look at how to describe a real-world graph. So if I look over here, it shows the graph of a height of a roller coaster during a single ride. So if I look at this, the domain, the time is going to go from 0 seconds to, I don't know, maybe 3 minutes. So this x-axis represents time, and this represents the height. So if you look at the height of this, my height is not starting at 0. My height is starting at, I don't know, maybe 3 feet, and it's going to go up to, I don't know, I can say 100 feet. So that's the parameters that I'm looking at. So if I want to describe this graph, and it's a roller coaster, how might this look in paragraph form? Well, it could be, for the first 30 seconds, you are riding out in your cart. You're not at 0, because 0 would be flat on the ground. You're starting about 3 feet up, so you're in the roller coaster, and you're not going up or down. So you're just leaving the, leaving the entryway, whatever that way is called in the roller coaster. So for the first 30 seconds, you are leaving the entryway, for lack of a better word. Then you go 97 feet or however many feet. Then you go super fast up a hill. And then you come right back down. Only to go right back up again at a very fast rate. Go right back up a hill at a fast pace. You get to the top and you drop down. You get to top of hill and drop down. Look at this. What does this mean right here? Well, it could mean you're going around a curve. So your height's not increasing or decreasing, but maybe you're going around a curve on a roller coaster. So then go around a curve, only to go right back up super fast. Only to go right back up a hill super fast. And then once you reach the top, you go right back down. Once reached the top, go right back down. And then it's staying the same height, so then you just smooth back into the entryway. Then just go back to the entryway. So that could be one way to describe this paragraph, right, as a roller coaster. Now, let's do it backwards. Let's sketch a graph given this scenario, okay? Now, the main thing here when you're sketching is you've got to label your x-axis and you have to label your y-axis. So in a single day, it snowed lightly during the morning, then heavily for the rest of the day. We're going to graph time on the x-axis, and we're going to graph snowfall amount on the y. So make sure you have that labeled. Now, it started snowing lightly in the morning. That means the height of the snow isn't going to happen real fast. It's just lightly accumulating snow. Then, in the morning, then heavily for the rest of the day, and then a snow blizzard comes in. So notice the height is getting a little bit as we go during the day, and then at the end of the day, the height increases at a steady rate because we're going straight back up. Okay? Now, look at Mia. Mia bought a painting. The value of the painting dropped by 25% after 1 year, then increased in value over the next 5 years, reaching a value that was twice what she had paid for it. Graph time on the x-axis, so here's time, and the value of the painting is going to be on the y. Now, she bought a painting, so her value is not 0. She bought a painting, and let's say she paid, I don't know, it doesn't matter. She's paying this much. Doesn't matter what your beginning point is. The value dropped 25% after 1 year. So let's say this is 1 year. And it dropped a quarter of it, right? So if it dropped 25% and I split this into 4 pieces, it dropped a quarter in 1 year. And after 1 year, it increased in value over the next 5 years, reaching a value that was twice what she had paid for it. So in the next 5 years, 2, 3, 4, 5, 6, it's increased twice of what she's paid. I probably should have made my beginning point down here, but you can see it's twice of what she paid. So that's what that graph is going to look like. All right, a basketball was dropped out of a window on the 2nd floor of a school. Each time the ball hit the ground, it bounced and reached a height that was half of the previous bounce. It continued doing this until it settled on the ground. Graph time on the x-axis and distance from the ground on the y. So where is this basketball being dropped? It's being dropped out of a window, so it's not being dropped at 0. It's being dropped out here. And it goes down, and then it goes back up of a height that is half of what it was. So it's going to go back up to half, then drop down again, then go back up to half, then drop down again, then back up to half, then drop down again, until it eventually goes flat. That's what that graph is going to look like. All right, let's turn the next page and look at number 5. All right, so Jace is speeding. Bad Jace is speeding on a highway and gets stopped by a police officer. The officer gives him a ticket and he continues on the highway. We're going to graph time on the x-axis and we're going to graph speed on the y. All right, so he's speeding on the highway. If you're speeding, let's say you're going 120 miles an hour, okay? This is speed. So Jace is speeding. He's staying at a steady rate, 125 miles an hour, that's a steady rate. And then finally a cop car comes and pulls him over. Well, his speed is quickly going to go down to 0. He better not be speeding, so he's going to stop, talk to the policeman. The policeman's going to issue him a ticket, and then he's going to continue his speed back up at a reasonable pace. Okay? So this means he's cruising along at a very high speed. He drops down to 0. The officer gives him a ticket, and then he goes steadily back up at a normal pace. Okay, so that's what your graph will look like there. Number 6, Carlos is a running back on his football team. He ran the same number of yards in each of the first 6 games of the season. After the 6th game, he did not play for the rest of the season due to an injury. Graph games on the x-axis, and we're going to graph total yards. Okay, so this is total yards, right? So he ran the same number of yards in the first 6 games. So let's say these are the first 6 games. 1, 2, 3, 4, 5, 6. 3, 4, 5, 6. And let's say he ran 10 yards here, and then he runs another 10 yards, and then 10 yards. 10 yards isn't very much. And then 10 yards, and 10 yards, and 10 yards. So he's getting the same amount of yardage each week, and that accumulates his total yards. Then he gets an injury. He doesn't play, but his yards remains the same. He's going to be steady at that yards, even though he's injured. They didn't go up or down. They stayed the same amount. So that is what that graph is going to look like. All right, let's look at Alice. Alice drives a school bus. On her morning route, she stops at every block to let students on. We are going to graph time on the x-axis and total distance. So this is total distance. So she's driving a school bus. So as she's driving, coming out of the bus barn, she's driving. She's going to stop to pick up students, and it's the same distance. And then she's going to drive some more, and she's going to stop and pick up some students. And then she's going to drive some more, and she's going to stop and pick up the students. And then she's going to drive some more, stop and pick up the students. And then even though she goes back to the bus barn, her distance is still increasing because it's total distance. Distance can't be negative, so distance is going to go up. So that's what that graph looks like. All right. Ray started his workout by running on the treadmill. His heart rate rapidly increased and remained high during his run. After the treadmill, he lifted weights. His heart rate increased and decreased during this time. So we are going to graph time on the X, and we're going to graph heart rate on the Y. Now, Ray's heart rate. Let's talk about Ray's heart rate. If your body is alive, your heart rate's not 0. Your heart rate is probably around 60 beats per minute. So I'm going to start Ray right here. Okay, that's where Ray's going to start. He's not dead. He's not 0. So he's starting on the, and then his heart rate rapidly increases, and it remains high during his run. So it rapidly increases, and it's going to remain high during his run. After the treadmill, he's going to lift weights. So once he gets off the treadmill, his heart rate's probably going to go down a little bit. You know, he's just calming down. He's not running so fast. And then he's lifting weights. So it's going to increase at some parts, then it's going to decrease, and then it maybe increase and decrease, and then, you know, it steadies. After he's done lifting weights, then we're going to come back to a steady heart rate. So that's what his workout routine is going to look like. All right, let's look at number 9. And now we're going to look and see Carrie, Luke, and Mason. Carrie, Luke, and Mason receive the same allowance each month from their parents. Carrie spent a small amount of money in the first half of the month, then she spent the rest of the second half of the month. So she spent a small amount in the first half of the month. So this is a small amount, and then she spent it like crazy. So this is going to be Carrie. Okay. Luke steadily spent his money throughout the entire month. So Luke is just steadily spending his money throughout the entire month. And then Mason rapidly spends his money, and he ran out. He had no more money to spend, so he ran out. So here's Mason. That's my oldest child. Not Mason, but that's what he does. He spends his money, and then he's out. He's done for the month. So that's what his graph looks like. All right, so reading a graph, the key takeaway points here, make sure you understand your X and Y and how they relate to each other. If you're struggling, come see me.